give you a couple of hints on that grade. So if you go to content and lesson 5, I've got homework 8, assignment and rubric. I've got the description, which I just went into. No, that's not it. Where did I put that? I gave you a little bit of a hint. Where's that at? Oh, you know what? It's embedded in the quiz 4 assignment. That's where I'm getting confused. So homework 8 and quiz 4 are highly related, right? Homework 8 is the SolidWorks files for that box, and quiz 4 is the physical box itself, right? So they're both really tied together. So if you go to quiz 4, the quiz 4 assignment, that's where I give you the hints. So it says you're going to make the box. Here you have critical assumptions. So I give you the base flange dimensions, the width, height, and height on the long side, and I give you a screenshot of that pictorially. Okay. Then I gave you the sheet metal thickness, the bend radius, and the bend allowance for use in your solid models. Okay, those are all parameters inside your inside the sheet metal part. Yes.
And on the main calendar, the class calendar, it says you must complete the base plate in order to finish quiz 4.
You're gonna need to. So I wish I had the model here still. Here, I'll.
It's the actual like big base plate of the test.
Yeah, let me show you why. It'd be easier if it was sitting right here, but I can pull it up electronically.
But when it says complete, like, does that mean accurate or?
No. No, get the dimensions.
Okay.
So let this open. This is the base plate down here.
Okay.
You need to have at least the dimensions. What I mean by you need to do the base plate first. You don't have to build the whole base plate, but you're going to have to at least get what from the base plate in order to properly finish your electronics box. You got to have the whole locations, and there's 4 of them. 1, 2, 3, 4 on the little flanges. So I'm technically not correct. You don't have to finish the whole base plate, but you got to get at least those dimensions. And maybe while you're measuring those dimensions, you might as well just measure all the dimensions for the base plate itself. Make yourself up a little sketch with some, scribbles, and then take it home and build up that base plate. You're gonna have to do it for the SolidCam final project anyway. Might as well do it. Now only one person in your group has to do that, and then they can distribute it to everybody else. Everybody has to do the sheet metal box for homework 8. Okay? All right, so let's go back over the homework real quick. So assigned tonight is you need to complete the SolidWorks Toolbox tutorial. Okay. Homework 8, which is that solid part and that drawing file for this electronics box. That'll be due Monday, uploaded to D2L. Everybody does that individually. You need to finish your sheet metal box, actually build it. That's quiz 4, but that's not due until Wednesday. Okay? Not due till Wednesday.
Will the shop be open over the weekend for us to do that?
Not this weekend, no. We may hold weekend hours if we find that you guys can't fit within our business hours to build the solid cam final project. But we simplified that project quite a bit so that we wouldn't have to hold weekend hours. Last year we had them build a part that was way more complicated than what you're doing this year. So hopefully we'll get away with that. If I find that there has to be weekend hours, we'll accommodate you. But that's not an excuse for not showing up after class. You have from 12 till 5, so it's a long time. Okay, I'm assigning homework 9 today. It's not due until Wednesday. Homework 9 is to create a third part and a drawing for your final SolidWorks project. So that's the project that you're doing individually where you're modeling something that you're interested in. Okay? So as part of that final project, homework 9 is to do a third part and another drawing for your final project. Okay? I haven't gone back and looked at the assignment for 9 to make sure it's up to date. I'll do that tonight, but it should be correct, yeah.
And homework 4, as long as we upload the breakdown file, you guys are going to print that out, right?
Yeah, homework 4 was due today. Homework 4. Yes, that you're going to. Did I assign that yet? Oh, I signed that on Wednesday. Yeah, that's due Tuesday. Uploaded to D2L. That's just the STL file, and then I'm going to send all the STL files over to ITL, and they're going to print them. Okay. I thought most of you. Oh no. So homework 4 is just the STL file. So you already have that because it was homework 2 or 3.
Yeah, it's just uploading. Right?
Yeah, it's just saving it as the right file format and uploading it. That's a 2-minute homework. So I don't want to hear any complaining about that one. Okay. And then we're also assigning the solid cam final project. You are ready to start on that project. So start forming your groups. If you have time, start measuring, taking that model apart and measuring pieces and creating your parts. It's not due until the Monday after the last day of class, but it's due. So don't forget to do it. Okay? And I'd rather have it by that Friday, the last day of class, so I can grade on the weekend. But I wanted to give you the weekend for some extra time. So if you need it, take it. Any questions on homework or anything before we actually get back to it? This is what I'm going to expect from your SolidCam final project. I want all these files. I want to hit open on the assembly, and I want it to pop up like that. Okay? Now, I don't take points off for stuff like things being transparent, but everything needs to be there, and it needs to fit. It needs to look basically correct. Yours will vary from mine just slightly because of differences in measurement, but the screws and stuff better go together. Okay? You better not have parts that physically intersect each other that couldn't do so in real life. Okay. I forgot to tell you guys too. I graded your templates last night, and a lot of them were highly entertaining. Thank you for that. There was some laughs in there. Some good creativity. Okay. We're going to go back to building a part off a part. So I'm going to jump in kind of quick because we're running out of time. Remember, we had this male part, and we want to build a female part that adapts off of that. So we're going to do that by making an assembly from the part. And remember, now the critical distinction is we're now in an assembly. We need to insert a component, new part. We're going to build a new part within this assembly. And then the really critical part is right now you're still in an assembly. You're not editing the part that we just made. So you have to go to this part, edit part, and see this little icon, and then you know you're editing the part. You're not editing the assembly. See up at the top it says we are now working on part 2, which is embedded in assembly 3. Okay. Now, I'm going to go ahead and view this thing like this. Remember, we're going to make the female part, and so when we did this male part here, you drew the sketch of this little U and then extruded it this way, right? Well, the female part goes the other way. So we're going to draw this U and extrude it back across the box this direction. Okay? So I want to be looking at this face here, and I want to draw my female part around this box. So the way we're going to do that is basically we're going to sketch off of this plane. So now I'm in a sketch of this part, and I'm going to come off of this edge just a little bit, horizontal line, vertical line, horizontal line, and there we go. So that's basically going to be my female part, and then I'll extrude it back, right? I'll extrude it back this way, and then I'll have the other half of the box. Okay? Now, now comes the adaptive part. We want to make this adaptive. So SolidWorks dropped in some relations in here. Okay? I'm going to go ahead just for clarity and delete those relations. Although these relations are kind of okay. I definitely want this line to be horizontal, this one to be horizontal, and this one to be vertical. These may end up biting us later, but let's just check it out. There are some things I definitely want when this box adapts. I want this female edge of this box to always be flush with the bottom edge of this box. All right? So to do that, and I want this edge to be flush with that edge. So to do that, I want this point, this point, this point, and this point to always be lined up. And that way I know that this female box will always be vertical. To do that, I may have to put in some points. So I may not, but I'm just going to do it anyway. All right, so that point's coincident with that box, and it always will be. This point is coincident with that box, and it always will be. And that means that I can make a relation that makes all 4 of those vertical. And since those other 2 points are always coincident to that male piece, and the female ones have to be vertical, that locks that in. So no matter how tall I make this box, that female box will grow based on those rules. Okay, there are other rules I care about. I care that the midpoints of these lines line up. So this female box will grow the same amount every time. So I need to do the same thing I did with those other edges. I need to drop some points in on the midpoints of these lines. Midpoint, midpoint. Okay, let's start relating them. So I'm going to want to add a relation, and I want this point, this point, this point, and that point to always be vertical. Let's add another one. Got to be careful. I got to clear these selections, and then I'm going to add this point, this point, this point, and this point to be vertical. Okay, like that. All right, now if you'll notice, if I grab this in either of these and I start moving them, I can move this one out here, I can move this one out here. I don't want that degree of freedom. And then this one has a degree, this one got locked in, and I don't think I want it locked in right now. So I'm going to kill this relation. It's still locked in on me. I may not be able to move that. But that's okay. Now, when we grow this box, you notice I can move this right there and move this a different distance. We can't have that, right? Those two legs have to be the same distance away from this male part to each other. So let's see, how do we want to do that? I think we could dimension it. And I can't remember. I think I like 0.07. 0.07 allows, because we're using 50 thousandths material, 0.07 allows us to allows for the bend radius, because this female part's going to have a radius at the edge. It's not a 90-degree angle. So that just has to do with the material properties, and we got that through trial and error. And I believe we want to make this one 70 as well. Now I don't know if this is always going to work. I don't know if this will adapt. But there we are. We've built that sketch off that part. So we'll test my theory. We may have to go back and fix this. Let's get out of the sketch, and let's extrude it. So we'll go to Features, Extrude, and it says it's going to go this direction. We don't want to go that direction, so we'll hit this button to change the direction. Sorry, this button to change the direction, and now it's going this way. And we want it blind, but we want it to go up to this face. So you can select up to surface and go up to that face and accept that, and now you've got the beginnings of this female part. So let's save this as something. Okay, you could exit the editing of this part, and if you wanted to now, you could click the female part and hit open, and you've created a part. There it is. And it's embedded within this assembly right there. Okay, so that's the beginnings of that part. Now, let's test and see if we did this right. I don't think we did it right. I think we're going to have to go back. But go into Matte General Mail, open the part, and let's change a dimension or two. So let's edit the sketch, and instead of 8, let's make it 10. Oops. 10 by 2. If we did it right, it should rebuild and adapt the other part. So I need to go to Assembly 3, change it, and it didn't change it right. You see our female part? What did it do right? Yeah, it did. The legs stayed together right there, but this didn't shrink, and this didn't update. But that part's not gonna update because that's your third dimension. You would have had to go into, if you're gonna change that dimension, you've got to go into this part and change the length. So we've screwed that up. Of course I screwed that up. So let's attempt to fix what I did. It all goes back to the sketch. So let's go back and edit that sketch. Alright, gonna go back to, we're gonna start over. We sketched it, but we're gonna do what I knew we should have done in the first place, which was we're going to kill all the relations. So those ones that SolidWorks put in, they hurt us. Alright, I still wanted it sketched sort of like that. So let's go in and add relations. Let's do our points. Vertical. Add another one. Oh, I just figured it out. What's wrong here? So this point and this point stayed vertical. What's wrong with this point? It's not the midpoint. It's not the midpoint. So I must have put that point in there and not defined it as the midpoint. So let's fix that. So we'll add a point. Yeah, so I dropped the point in on the midpoint, but it did not make that point a relation. So we need to go to those relations and make sure that that point is the midpoint. And it is. but I wonder if it's going to stay. That point, existing relation, it's the midpoint. That should work. This should work. Okay, let's add another relation. These need to be vertical. Is it just me, or did they not get forced to vertical? I think I might have picked the wrong point. So I'm going to delete that relation. Add relation, point, point. Point, point, all vertical. There we go. Jeez, thank you. It's really picky about selections. So those are vertical, those are vertical. Now, we still have a degree of freedom here, so I'm going to drag to show it to you. So I can pull this, right? And I can pull this. Now, I don't want this one to be able to pull differently than this one. So I think what we'll do is we'll relate the midpoint of this guy to the midpoint of this guy. And that way they would be forced to be there. So, midpoint, yes. Midpoint, yes. Let's add a relation. U and U have to be horizontal. Okay? Now if I try and drag this, I can drag that out that way. But if I drag this, check it out. Both of them move. Right? But that one's being goofy, right? So how do we lock that down? Line has to be horizontal. Add a relation. U, horizontal. And now I can pull this like that. And I can pull this like that. Oop, that other one has to be horizontal. Okay. Now I can pull this like that. That's cool. Pull this like that, and it automatically comes in. We got a problem over here. As I pull this, you know, this point in space is goofing around. So that's no good. So I think, I don't know what I did with this point, but I'm going to delete him. I'm going to delete him. I think what I did is I didn't make those coincident. So let's go ahead and add a relation that makes that, 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 and that. That did not do anything. So let's find the vertical relation. I think it's because these points aren't in here. So let's add a point. And this time I've got to make sure it's coincident with that. Coincident, yes. I don't think I made sure of that last time. Coincident, yes. And now let's add a relation. Let's add a relation that says that this guy, this guy, this guy, and this guy are vertical. Hallelujah. Are we there yet? All right. So now if I drag this, that stays together. Okay. So that's what we wanted. That was our design intent. The one last thing we need to do is define a distance between the two boxes, and that was going to be that dimension of 0.07, and that'll never change regardless of the size of the boxes. So we'll go ahead and we'll dimension that, and that came from trial and error from playing with the material. So we're going to make that 0.07 inches, and it'll never change, so we don't care. All right. So there's my adaptive part. Now it's not fully defined, and I believe it's because we didn't make this thing vertical. We could make him vertical. And we're still not fully defined. We probably could drag that around, but I'm not going to do that for now. Let's exit the sketch and exit editing the part and go back to the assembly. Look what happened. Remember I changed it to 10 by 2 and it didn't fit before? Now it does. Alright, so let's go back to Matte General and change that base flange dimension. Oops. Edit the sketch and change it to something even goofier. 20 by 12. Exit. It'll rebuild that part, and the female adapted to that part. Okay. Now the one last thing we don't have is we don't have the female adapting to this side, and that has to do with the extrusion. So that would be in the feature, and we want it up to surface. It should always be up to that surface. And hopefully that makes it such that it'll always work. Let's try that. Let's try and change it again. 8 by 1. No, it hosed. I'll have to show you that next time. No, it did it. We've got an error. We got to figure out where the error is. Oh, it's the holes. I made it so thin that there wasn't room for the holes anymore because I made it a little 1-inch part. So let me go back to that. Let's not make it so thin. Let's make it 3 inches tall. Notice the female box is now adapting no matter what we make the dimensions. You see what happened? That cut extrude failed. It's because the distance between that hole and that hole is more than 1 inch. So I can't possibly have this shorter than 1 inch. So that's building parts off of other parts and making it so they adapt. That's really, really useful. That's how I made that little electronics box in that big assembly that you're going to build. I built the assembly, I put the boards on, and then I built the box around those boards and affixed to the base plate. So it's very useful. We may next time go into finishing this and adapting it such that the holes will always line up. That's another trick. I know this was a little tricky, but we figured it out, and it's on video, so if you need to see it, you can watch it again. And it was good that we ran into some of those problems so that you can see what the problems were. Does anybody have any questions before we leave? And questions on the homework? Yep.
So, do we need to go physically measure, or on this document are there all the
What's not on the document is the locations of the 440 holes that screw it to the base. So you would at least need that. And there's, no, I lied, there's even more. If you look here, and you'll find this out when you go to start looking at it, the dimensions I gave you were the ones that were absolutely necessary to get it to fit in the volumetric constraints. So I gave you this length and this width and this height here. What's missing is stuff like the diameter of this hole, the diameter of this hole, the diameter of this hole, the location of that hole on this face. Same with these, the locations of these holes on that face. So there's a lot of stuff missing. You're going to need to get that. So yeah, you guys are going to have to measure today in order to get it tomorrow. But if you grab that box, I think you guys could measure that up in 10 minutes. And if you all want to be sitting there and hovering over each other, maybe one person only has to measure it. Pick the one that got the best grade on the measurements, and then you can just copy off that person if you like.
On D2L, I added a link to the motor webpage, so you can see exactly what motor we're using, the shaft diameter of the motor, and the holes to mount the motor to the plate, as well as documentation for the large gear and the smaller gear, and a resources picture that kind of explains the terminology for the gear. We didn't really cover that, but it's pretty simple exactly where to put the gears relative to each other to get them to mesh.
And that's for your solid cam final project, so that's resources for you. Where's that under?
It's on D2L, solid cam final project.
Content?
Content. Solid cam final project files.
So here's what he's talking about. Use that as a resource for helping you mesh these gears. So those two gears, you can imagine in order for those to mesh properly, what has to be correct? Distance between the centers of the shafts. So you're going to have to get that right. And what Professor Hodgkinson is telling you is you've got some hint files here to help you out. Any other questions?
So, what exactly are we doing for homework?
One more time. All right. So you've been assigned today to complete the SolidWorks Toolbox tutorial. Homework 8, which is to create the two files, the part file and the drawing file, uploaded to D2L. That's due Monday morning. Quiz 4 is assigned. That's to actually finish the hardware sheet metal box, to actually go cut it out and bend it. But that's not due until Wednesday, but it's assigned. You're also assigned homework 9, which is a third part and drawing of your final SolidWorks project. That's the one that you're working on yourself, a unique thing. And then you've also been assigned the Solid Cam final project, which isn't due till the Monday after class ends, which is modeling the parts and assembly for that controls lab.
And homework 7 is also due on Monday?
I didn't think so. Homework 7 was, I haven't even assigned it yet, have I?
Yeah, you signed it yesterday. It's creating the 2 parts.
Oh, that's right. Nope, due Tuesday on the calendar. This is all on the calendar. So there shouldn't be any confusion. It's all on the calendar. You'll know it's due on the calendar. At the top it says collect. So if I'm going to collect it, it's due right then. Okay? Any other questions? So the only caveat, Byron, was homework 8 to get that sheet metal box catted up properly, you're going to have to take a few dimensions off that base plate, right? Right here. You're going to have to at least get the dimensions of these holes on that base plate, right? In order to get them to line up right. Okay?
What about quiz 3? Is that due
Quiz 3 was assigned today, and I just made it due Tuesday.
Okay.
So that's your drill and tap quiz. It's due Tuesday morning. What's that?
That's the one that Yep.
That's he's. Oh, you're gonna hand it out now?
Well, I hand out the paper portion and then the drawings. So you're gonna have your assignment on the Excel sheet for the drill and tap quiz on D2L. I'm working on uploading that. That should be done here in a couple minutes. And then if you get depending on the assembly file that's assigned to you, either part A or part B, those drawings will be in a manila folder in the same box in the machine shop as the aluminum and steel pieces. So you'll get the aluminum piece, the steel piece, write down all your solutions for the assigned screw holes on this piece of paper, fold up that piece of paper along with your completed parts, and put them in a baggie that will also be there, and that's what you'll turn in. Does that make sense?
It's easier than it sounds. You're going to be taking 2 plates and drilling and tapping a hole in each of them. Where you drill that hole, what size that hole is, what size the threads are determined by your assignment. He's going to give each of you different ones. And that'll be on this spreadsheet that's on D2L here. Assigned assembly screws, I think. But he's going to change this, so give us a day on that, or at least till this afternoon. But can we hand these out now then?
We'll hand this out now.
These?
Don't hand those out yet, because I don't know which one.
Okay. And if there's more confusion on that Monday, we'll go over it. And if we have to, we can even extend that due date. That wouldn't kill us. So let's just revisit that Monday. Anything else? I told you this class was going to ramp up. It's not going to be boring anymore.
Yesterday we said that we are gonna get 2 take-home quizzes.
Yes. So quiz 4 is take home. That's the box. And quiz 3 is take home. That's this drill and tap. Right. Quiz 4 is to make this box.
Okay.
It's take home. I mean, you can't do it in class. And then quiz 3 is this one he's just handing you out. You have to actually drill the holes and tap the holes. So you're going to have to, that's a take home. Can't do it in class. You do it in lab afterwards, right? Okay, anything else? Sorry for all the confusion, but I think you'll find if you just start doing them, that they're not that long. All these things are about 10, 15 minutes. It's not that, some of them are, most of them are.
Oh, and then the sheet metal parts for the box. Do you guys want